Hi everyone. Here we go with the final notes of our unit, which is solving radical equations. Let's begin with questions 1 through 4. We're going to solve each of these equations for x. So number 1, x minus 4 equals 8. In order to solve this, we're going to add 4 to both sides, and we get x is equal to 12. Number 2, x plus 2 equals 5. To solve, we subtract 2 from both sides, so we get x is equal to 3. Number 3, 4x equals 20. We solve by dividing both sides by 4, and we get x is equal to 5. And last, x divided by 6 equals 3. We solve by multiplying both sides by 6, and we get x is equal to 18. So take a moment and consider 1 through 4 and see, what do you notice as a pattern or something that each of these have in common in terms of the steps used when solving. So what do you notice? Is there any trends that we follow? And then you can go ahead and write your answer below number 5. One thing I noticed is that for each of these, we use the inverse operations in order to solve. So if in number 1, if we're subtracting from x, we add to both sides and it cancels out and we're just left with x. Number 2, when we're adding, we subtract from both sides and that cancels out. Also, number 3, dividing cancels out with multiplication. And number 4, multiplication cancels out with division. So we notice that we used inverse operations to solve. And that's always going to be true for any algebraic equations. We're going to use inverse operations to solve. So if we're solving radical equations, you bet that we're going to be using the inverse operation to radicals. All right? As a refresher, inverse operations are pairs of operations that undo one another. So for instance, addition and subtraction are inverse operations of one another, and multiplication and division are inverse operations of one another. Can you think of any other pairs of inverse operations? Based on what you already know about radicals, what do you think is the inverse operation of taking a root or a radical is? Go ahead and write your answer below. The inverse to taking a root or a radical is raising to a power. So powers and radicals are inverse operations of one another. Okay, so when solving radical equations, we're going to be raising both sides to a power. All right. So let's take a look at the steps needed to solve. So step 1, we want to solve for the radical term. Or in other words, we want to get the radical by itself. We don't want any numbers in front of the radical or attached to it on the outside. If there's radicals on both sides of the equation, then we want to get all of the numbers on the outside to cancel away, right? We just want a radical equals a radical. In this case, we only have one radical, so we want to get this by itself. In order to do this, we're going to do our reverse order of operations. So if you remember, PEMDAS, or please excuse my dear Aunt Sally, stands for parentheses, exponents, multiplication and division, and addition and subtraction. We use PEMDAS, the order of operations, when simplifying or evaluating expressions. We use reverse PEMDAS, so in the opposite direction, when solving. So in this case, I'm looking for any addition or subtraction. I'm going to deal with that first. I notice that we have a minus 8. So in order to undo that, I'm going to do the inverse operation to both sides, which is add 8. On the left-hand side, it cancels. On the right-hand side, we get 6 plus 8 is 14. All that's left over on the left-hand side is 2 times the square root of x plus 4. We've dealt with the addition and subtraction. Now we can deal with the multiplication and division. I notice that out front we have 2 times the radical. So to undo that, I'm going to do the inverse operation, divide both sides by 2. On the left-hand side, it cancels, and we're just left with the square root of x plus 4. And on the right-hand side, we have 14 divided by 2, which is 7. Step 1 is done. Step 2 is to cancel the radical or radicals by raising both sides to the corresponding power, or the inverse operation. So the power that you're going to raise it to is going to be the same power that the same index as your radical. So in this case, we have the square root, or an index of 2. So we're going to raise both sides to the second power, or square both sides. The inverse to a square root is squaring, and vice versa. The inverse to squaring is taking the square root. So we're going to square both sides, and that's going to cancel out the radical and the square. And all that's left with, that we're left with on the left-hand side, is x plus 4. On the right-hand side, we have 7 squared. So 7 squared is 7 times 7, or 49. And then finally, step 3 is to solve for the variable as usual. We're going to subtract 4 from both sides, and we're left with x is equal to 45. And that's our answer. All right, let's get some practice on the following page. Example 1. 1a, here we have 4 plus 3 root x minus 2 equals 22. So to solve this, we'll first subtract 4 from both sides of the equation. And we have 3 times the square root of x minus 2 is equal to 18. Next, we divide both sides by 3. And so we have the square root of x minus 2 is equal to 6. To cancel out this radical, now that we have the radical by itself, we're going to raise both sides to the second power, or square both sides. So we have the quantity x minus 2 is equal to 6 squared, or 36. And finally, now that the radical's gone, our last step is to add 2 to both sides. And so we have x is equal to 38. 1b. To solve this, we'll start by dealing with the addition or subtraction. We're going to subtract 7 from both sides because we have a positive 7 out in front. And on the left-hand side, it cancels, and we're just left with negative square root of y plus 8 is equal to, well, negative 2 minus 7 is negative 9. I want to get rid of that negative out in front of the radical, so we're going to divide both sides by negative 1. I'm left with the square root of y plus 8 is equal to positive 9. And then to get rid of that square root, we're going to square both sides. And notice that every time that I'm squaring, I'm using parentheses because I want to square the entire side. So on the left-hand side, we're just left with y plus 8. That square root and square cancel out. On the right-hand side, we have 81, 9 squared. Finally, subtracting 8 from both sides gives us our answer of 73. Okay. Letter C. So I noticed that we have a radical equals a radical. So we want to get rid of anything outside of those radicals. Fortunately for us, there's nothing on the outside of either of these radicals. So now, in order to get rid of these radicals, we can just square both sides. And notice what happens here. On both sides, the square and square root cancel each other out. So we're just left with the linear equation 2m plus 14 is equal to 5m minus 4. Those radicals go away when we square both sides. So now it's just as easy as solving for m. I'm going to subtract 2m from both sides. And we're left with 14 is equal to 3m minus 4. Adding 4 to both sides, we get 3m is equal to 18. And finally, dividing both sides by 3, we get m is equal to 6. Letter D, again, we're going to square both sides of the equation. We don't have anything attached to these radicals on the outside. So squaring both sides gets rid of those radicals. So we have r plus 5 is equal to 4r minus 25. Subtracting r from both sides gives us 5 equals 3r minus 25. Adding 25 to both sides of the equation gives us 3r is equal to 30. And finally, dividing both sides by 3 gives us r is equal to 10. All right. This is most of the lesson, but there's one more thing that we have to talk about, and that's extraneous solutions. An extraneous solution is a solution that emerges when solving the equation, but is not a solution to the original equation. When considering roots or solutions to a function, an extraneous solution is not part of the domain of the original function. And I'll even underline original function. it's a solution that doesn't work for the original equation or function. Is there any number that cannot be the radicand of an even indexed radical? Or an example of that would be if we were taking the square root, which remember is the index of 2. So if we take the square root, is there any number that we can't take the square root of? Take a moment and think about it. Is there any number that we can't take the square root of? Well, the answer is any radical with an even index. So that's a square root, fourth root, sixth root, eighth root, and so on, cannot contain, have you figured it out yet? A negative number as the radicand. Like consider if we had like the square root of -9. We know that the square root of +9 is equal to 3. Remember, the square root is saying what number times itself is equal to the radicand. So if we take the square root of 9, that's saying that 3 times itself is equal to 9. But consider the square root of -9. Are there any two numbers of the same, or any one number that we can multiply by itself that gives us -9? Well, sometimes students will say like -3. Okay. But if we have -3 times -3, again, that gives us +9. So that's not a solution there. That doesn't evaluate to -3, I should say. Okay, there is no number that we can multiply by itself in order to get -9. Because in order to get a negative, one of them has to be positive, one of them has to be negative, which would cause those numbers to not be the same. There is no such number. Solutions to radical equations that cause the original radicand to be negative are extraneous. So what we have to do is we have to check our solutions and plug them back into the original radicals to see whether or not it causes the radicands to be negative. All right? We cannot have a negative inside the radical. We cannot have a negative inside the radical. So let's see what that looks like. Let's try a few. On the following page, example 2. So now we've seen examples like this. A square root equals a square root. In order to solve this, I'm going to square both sides. Squaring both sides, we get 4x plus 8 is equal to 8x plus 20. And notice that that gets rid of the radical on both sides. Solving for x, we can subtract 4x from both sides. And we're left with 8 is equal to 4x plus 20. Subtracting 20 from both sides, we get -12 is equal to 4x. And then dividing both sides by 4, we get x is equal to -3. Okay, now we have to check. This is where we check whether or not this solution of -3 is extraneous. So I'm going to go into both of these original radicals and plug in -3 for x and see if that causes my radicand to be negative. So in the first radical, here's our check. In the first radical where we have 4x plus 8, I'm going to plug in -3 in for x. So we have 4 times -3 plus 8. Well, 4 times -3 is -12, and then plus 8. And evaluating that radicand, we get the square root of -4, which does not work. We cannot have a negative inside the square root. So because this causes the radicand to be negative, we have to eliminate this solution. It's not a real solution. This is an extraneous solution. So our answer to 2A is no real solution. And what that means is that the solution to this equation, this radical equation, is a non-real solution or an imaginary solution. And we'll learn more about that in Algebra 2. All right, let's try 2B. So here we have 2 times the square root of the quantity 4 minus a minus 9 equals 13. So to solve, I'm going to add 9 to both sides. And I get 2 square root of 4 minus a is equal to 22. Dividing both sides by 2 gets the radical by itself. So we have the square root of 4 minus a is equal to 11. And then to get rid of that radical, I'm going to square both sides. So I have 4 minus a is equal to 11 squared, or 121. Subtracting 4 from both sides, we get negative a is equal to 117. And finally, dividing both sides by negative 1, we get a is equal to negative 117. Now we have to check to see whether or not this solution causes this radicand to be a negative number. So if we plug in into the square root of 4 minus a, we have 4 minus, well, a is negative 117. So we have 4 minus negative 117. And subtracting a negative is the same as adding a positive. So we have 4 plus 117, which is equal to the square root of 121. And 121 is positive, so we're good. Actually, this solution works. So we do not eliminate the solution, a equals negative 117. That is our solution. And I just wanted to include this as an example because the solution can be negative. Okay, your solution can be negative, but your radicand cannot. So that's why we check the radicand. All right. We got one more for us today. Letter C. So here we have a radical equals a radical. In order to solve, we're going to square both sides. And so we're left with 5 minus 4g is equal to 2g plus 17. Those radicals cancel. Adding 4g to both sides, we get 5 is equal to 6g plus 17. Subtracting 17 from both sides, and we get negative 12 is equal to 6g. And finally, dividing both sides by 6, we get g is equal to negative 2. We have to check in both of the radicals. So we'll do the left-hand side. We'll do the square root of 5 minus 4g. Well, g is negative 2, so we have 5 minus 4 times negative 2. Well, we have 5, and negative 4 times negative 2 is positive 8. So we have 5 plus 8, which is equal to 13, which is positive. So that radical checks out. Let's check the other one. So we have the square root of 2g plus 17. So 2 times negative 2 plus 17. Well, 2 times negative 2 is negative 4, and then plus 17. Negative 4 plus 17 is 13, which is positive, so we're good. So again, our solution is negative, but this solution is a real solution to the equation. All right? So in summary, the inverse operation to a radical is a power. In most cases, if we're doing the square root, then you're going to raise both sides to the second power, or squaring both sides. And finally, we have to check for extraneous solutions. Extraneous solutions are any solutions that cause the radicand of an even index radical to be negative. Okay, so can't have a negative inside the radical. All right. I think that's been enough for today. So we'll get a lot of practice on this in class. We'll see you tomorrow. Have a great day, everybody. Goodbye.